many of you have suffered from COVID-19 even after getting vaccinated? If you had come into contact with SARS-CoV-2, which is the virus that causes COVID, and became sick, this is likely due to your body's slow response to this foreign agent. When pathogens such as bacteria or viruses invade the body, they attack and multiply. The immune system uses several tools and mechanisms to fight off this invasion. Where after its victory in combat with a disease, the immune system remembers what it learned from battle so that it can respond quicker the next time it comes into contact with the same pathogen. Vaccines have greatly reduced the risk of infection by working with the body's natural defense mechanisms to safely develop disease-fighting immune cells called B and T cells. However, it typically takes the body's weeks to a month to produce B and T cells after a vaccination. This is why it's possible for a person to still get sick even after being immunized. So my question here today is it possible for our bodies to develop immunity without having to first get sick? Is it a way to recreate these disease-fighting immune cells to bypass the weeks or months it takes for our bodies to naturally produce it after a vaccination or illness? Well, in this study, I set out to answer this question with B cells. B cells play a fundamental role in the body's immune defense through the production of antibodies. Plasma B cells have long lifespans that allow them to produce antibodies for decades, giving them the potential to provide a disease-specific long-term treatment for a wide variety of diseases or autoimmune conditions. Sadly, the production and engineering of these specialized disease-fighting cells have remained very difficult. The main barrier to producing these powerful cell lines for clinical use is the recreation of the germinal center reaction. Germinal centers are where disease-specific B cells are created. 3 key steps are needed to create the disease-specific B cells within a germinal center, and that is 1. Initial exposure to pathogen, 2. Entering the germinal center, and 3. Cellular contact with specialized activating cells called T helper cells and follicular dendritic cells. These cells carry important signals called antigen that are needed for B cell activation. Many researchers get stuck at this last step, which is mimicking the interaction between B cells and follicular dendritic cells within the germinal center. Currently, researchers approach this problem using genetically modified cell lines. However, this approach is highly complicated, non-quantitative, unreproducible, and often leads to rapid B cell death. Thus, there's a great need for a fully synthetic approach that doesn't require the use of genetically modified cell lines. We hypothesize that the use of a synthetic particle that mimics the fluidic membrane of a follicular dendritic cell will have a more profound effect on the activation of B cells and completing the germinal center reaction. Using liposomes as our synthetic particle, we hope to provide a more quantitative, reproducible, and reliable system to mimic the germinal center reaction, giving rise to a line of powerful disease-fighting cells that can revolutionize the way we approach vaccines and cellular therapy. So imagine being injected with powerful immune cells instead of being injected with the disease itself.